see some parameters, so we will go up and we will discuss how to build it. Okay, so did you open your files?
Yes.
It's okay, yes. Thank you. Okay, so
When exactly should it be?
what?
Which file should it be? In Jupyter.
Jupyter Notebook, you should open auto-encoder stud. Can you find it? Okay, so let's try to start to build our deep autoencoder. And the first step is downloading your data. Your folder consists of two JSON, hard JSON and calories, and you should download your data. Here you can see your first block is importing the relevant modules. Please make like, I can't show you here, but you should press here and then press run or shift enter like a shortcut. And this block will run. It's important. Nobody has no mistake. I hope.
What we should
Repeat once more?
Yes.
You should press on importing the relevant modules and press shift enter. On your laptop or maybe computer. Does it work? No red errors. If you have no red errors, that means that you always good, so you can see something like this. Oh, you see some activation. It's not like in lecture, yeah? You should do something with your hands. Some questions, girls? This one, yeah. But here, press here, run. It's okay. As I said. Okay. Some questions? I can. So you run this and then you should print something here and I'll show you what you should do. Okay, I have a little questions. Are there some person who doesn't know something about Python? Because you, why? I had some information that you should know Python.
I know the same from statistics.
Yeah, it's possible to do it, but Python has some possibility more than statistics. You know, you can build some auto-encoders. Yeah, I can create my systems using some layers used by Python. It's really a good idea. I have no, I think in our world there are no such powerful application for data mining right now. In our modern world is the best application. All researchers use Python for these tasks. So, like statistical model also, Python is really powerful. You can use Python also because you can visualize your data by different ways. So much information you can find here. Okay, attention please. It will be complicated for people who don't know Python, but I will show you what you should do after somebody obtains some result. Here you see the next part of your code, the next block, is something with missed values, like here, sorry. I'll show you, so you see this. You should add here some code. First, it's about first line. Second is about second line. Third line and fourth line. So you should add 4 parts of code. First should be create data frame with name hard, you see hard here, using PD data frame, and that's all. So you should print hard point PD data frame. Oh no, here, no, sorry. You should use only PD data frame. Hard is equal PD data frame. It helps you to create data pandas data frame, empty pandas data frame. The second line is to create the data frame calories by this way, like calories is equal to PD data frame. So you create two empty data frames, hard and calories, and we will work with it. Who have no possibility to do it right now, have no knowledge in Python, please wait 3 minutes, I'll show you what it should be and you will print it really quickly, okay? But you can try to build it using my description of this process, is it possible? So please. If anybody has some question? So first row should be hard is equal to PD data frame, bracket. Second should be calories is equal to PD data frame, bracket. Third should be hard is equal to PD rate JSON. Inside brackets should be heart rate JSON with these single quotes, like quote, heart rate JSON, quote. So you download in your data frame heart information from JSON file. And calories, you download to your data frame calories information from your JSON file, calories JSON. Please, 4 actions. I think it's easy. So please print. I try to understand is it possible to finish.
After heart,
what role?
second step is just to write calories.
Calories is equal to PD data frame, bracket.
Is equal.
Heart is equal PD data frame. Calories is equal to PD data frame. It's like empty data frame. We just said to Python that it will be data frame without data. And then we download here by the method PD read JSON information from JSON. The JSON is at the same folder, so we just download this information. It's somebody did it?
Yes.
Oh, we have winners here. That's good. So, I can show you. Can I show you what code should be?
Yes.
Okay, here it is. You see, I'm not sure that maybe, 1 second guys, I can do it like this and like this. It will be less information, but it will be bigger. And maybe again. Oh, is it good? Can you see? Okay, when you did it, PD data frame for heart, PD data frame for calories to create empty data frame. Then read JSON for heart rate JSON and download information from this file to heart and from this file to calories. That's all. Then please press here and press Shift Enter or Run. Then you should see something like this here. Guys, here it's about information inside your JSON file. Here you see data type and see some value. And you can see this value is presented by a little dictionary with beats per minute. It's information about your heart rate, beats per minute, and some level of confidence. Our smartwatch use some level of confidence to be sure that this beats per minute is good value. And you can see here beats per minute and some level of confidence. Okay, then you can move to calories, and also I can do it, but you can press run. If your JSON file was downloaded correctly, you can see information about your calories. At the same date time, the value of your calories, your, how to say, that was lost by your body in this period of time, something like this, yeah? So, does it work? Yeah. Okay, it's good. Then, okay, let's move. Cleaning the training data. So we have some information. I move here and I see. Here we have some dictionary. We have no need to have dictionary. We need only this value, 54. It's first point. Only our heart rate, yeah, beat per minute. And then we should use, you see, the data time is like 5 seconds, plus 5 seconds, plus 10 seconds, plus 5 seconds. Oh my God, it's like with different time values of time, yeah, we have such I forgot the word, sorry. Such a number of beat per minute with different values of time. So maybe it's not correct. I want to calculate a mean between, for example, we should measure 1 per minute, but the smartwatch did it 1 per 5 seconds. So let's reprocess this data in some way. Okay, so here you should sort your values using sort values method by the parameter date time. So you should, it's first line, you should print here heart is equal heart point sort values, and inside brackets you should print by equal date time. So you should sort all your data frame by date time from beginning of day or of hour or of month to the end of month, to be sure that our timeline is good. It's from beginning to end. And then it's first line, and then you should set index as values of column date time, like set index. So, I don't know, as you know, I want to say as you know, but I'm not sure as you know. So, Pandas data frame uses some specific indexing of each data frame. So, we should use date time like our index, because it's really simple to process data when we have index like our data time. So, we should print here heart point set index. Inside we should print date time. And do the same in other block calories. Also set value, I think, sort values by date time at set index like, but here you see set index like time, because in calories data set, I'll show you 1 second. In calories data set we see time. I'm not sure that time is correctly, because maybe daytime. Sorry, I see it in. I think. No. It's like it's a different step. We name calories values and a column like time, and we will set the time like our index. Yes. And then you can do it, and I tell you something about pre-processing steps, because as you saw, we have dictionary in our data set, and we want to find in this dictionary only value of beat per minute. So we should do the following steps. We should change the type of our data from dictionary to string by making applying string to our rows of our data. Then we should split our strings from values bits per minute. So we should delete this part BPM 2 points and drop it. We don't have no need. So we did it by this string. Here you can see that we split it and then we will drop it. And also we should split comma because we have bits per minute, 2 points, our value, and then comma. So we should split using comma, like a split method. And then we can change the type of our data as integer. So this data is not integer, this is not integer, integer only 54, for example, it's like a number. And then we will resample our data to the value of 1 minute using our data, date time, and we will calculate mean for each minute of our data. And then we will round this value to, for example, we will summarize, we will calculate a mean from, I don't know, 20 time points, and then we will have some value like 53.2. So we should round it to have only 53. Is it works? Does it works? Guys? When we did first step, you were more active, right? As right now. I don't know why. So I can show you code to make our process. You can see here hard sort values by date time. Hard set index like date time. All that it was in my presentation, nothing else. And it make my data set like this. Date time and only values. So that information that we wanted to have. Can we move on? No, okay. We won't.
Maybe enlarge it a bit.
What?
Maybe enlarge it a bit.
It was, I think, maybe, 1 second, sorry. Like this.
Yeah,
When you put all text you need, please run this cell, and you will see data frame like this.
But it shows an error and it says that none of date time are in the columns.
Did you press run on previous cells?
Yes.
Please start from beginning, press again. I think some cells didn't run. Is it works?
How can I understand that it's working?
You see this data frame? Or maybe mistake, someone works, I don't know.
Key error, trace back. Як я запустив? Повністю.
From beginner, please. But never run all cells, because all cells start the learning of your auto-encoder, and it's not for today. Does it work?
Yes.
Okay? Can we move on? A little.
Can you help us, please? I just don't understand what I am.
Who you are? Sort index and by the time, I think it should be no, without by. Set index. It says you no by in set index. You should use without by.
I don't have like.
What? It's real. Sorry, I can't.
You should jump.
I didn't want to jump. What? Okay, press run here. Maybe it's not connected. You have error in your Jupyter notebook. You see, not connected. I don't know why. No, it's not about internet. It's about your kernel. Your kernel is not connected to Python.
Там ошибка дата тайм.
Can you? There is no access name data frame for object. I tried But by data frame, data time. Oh my god. I don't know why. Sort values. So set index. Can you see some differences in this code and your code? All will be okay if you print the same as in my screen. Please see some different letters, but I don't know why this computer. Can you maybe change your computer, or maybe can you join to a partner? Okay, it works. Then the same with calories. You see here, calories sort values by date time, and calories set index by the time. And after this, you will see some data frame. Who told me that these guys will know Python? Who it was?
Maybe Python is a large snack.
Maybe.
Everybody knows this Python in Zoom.
But they should. Is it okay? Calories. Why? Mistake? Error?
Still hot.
K error data time. In brackets. Why so?
Date maybe, and not data. It should be date time. What did you?
Date time.
You see, Python shows you all your mistakes. Please correct it. Not sort index,
For
not.
some reason, it's does not display the data. It's sorted.
Maybe.
Yeah, it took some time.
Yeah. It should.
Now it's right.
You can see here, guys. Can you see here how many rows has your data? That's why I said so. To process this data, you should have a lot of time. It depends on your computer, on your laptop. Can we move on? Okay. Then, the next, you should merge. What? Wait, okay. I know. Is it good? Okay, fine, information. Okay, right now you should merge your data set. Merge, it's like make from two data sets one data set. And for this, you should create empty data set using PD data frame, as you did at first step. Empty is PD data frame with two brackets, like empty, yeah? But it's not a PD data frame by default. Inside brackets, you should give some parameters to this empty data frame, like PD date range with these parameters. Maybe I should show you a code and not wait, because we have only 1 hour to the end of our workshop, and we... PD is pandas. Pandas is like a big part of Python that helps to create the structure like this, to present you data by tabular view, by comfort for your eye way.
So it's just how I want to see the data.
But yeah, how to see the data, but Pandas inside has so many methods for processing your data, for calculating means, to build in some graphs, histograms, and so on. It's like a big application for data science, for data analytics. It's really useful to use Python for your data analytics. And if you want, you can do it by matrix. It's like NumPy array. You can use this and make mathematical calculation, but in NumPy you should use formulas. Formulas, you should print it, you should create it, and here you can use some like tuned for you methods for data processing. And these methods are, the number of these methods is so big, so you shouldn't use other applications for data processing. Idea. What? Okay, guys, merging. It's about pandas. Maybe some guys wanted to do it by their hands. So here you should create pandas data frame with some date range, start from this, end from this, with frequency 1 minute. So you should create some properties to your data frame for this. And you should name columns of your empty like date time index. So this data frame empty will use some date time indexing for your future big merging data frame. Because you see that we change our heart rate by using some specific date indexing, yeah? And then we should use it for calories also. And to merge it together, we should find like how to change it, some way to be changed, to this data be changed. And this empty data frame will be this, like, I want to say word, but I forgot it, so I translate it. It's like some, I don't know, it will be like a sample or maybe some template for your data to create your particular data frame. Then we will use, I'm sorry, I'm going here, okay. Then we import some module, reduce, and then we use this module to merge your data by left-right merging, and your data will be your hot data frame, your calories, and your empty data frame. Then we will use the special name of your columns, and then we will drop all missed values, because when we do it, some values can be missed. So we should drop it and do not use. When all will be okay, when you run this cell and you see this data frame, where we have a date, where we have a time, the value for heart rate beats per minute and for used calories. It's our principal goal. Here we prepare our data for processing because we have different time series and we should make one particular data frame. Is it good, guys?
Yes.
Okay. Maybe I should ask before our lecture, how was your level of Python coding? Yeah, hello world, that's good.
-0.
Yeah,
Sorry, I pressed shift enter, but nothing.
but you should wait, maybe.
I waited like 3 minutes.
Nothing happens, no errors, you should wait. Some computers show not alone. Maybe you can, when you value error. And what else? Value error, what? Invalid syntax. It's about this one. No, here you will have it because you have in previous steps some invalid, some errors. One, what it was?
Нормально, сегодня все будет процесс начинать.
No. I can see this way. Can you compare with my code? Maybe you will see some mistakes. Are there anybody with correct answer? Oh, Sasha, thank you.
Саша, дай сфоткай мне предыдущий шаг. Спасибо.
Is anybody else?
Ну ты молодец, спасибо.
Guys, anybody else? No? Why? What problem you have?
Errors.
Errors, why? Can you please read your error?
Need to rerun column in series to apply key function.
You can apply key function to your series. And what is the number of row here, or maybe what row? It shows you the row.
5,298.
No, it's about, it's not about the row. So what row of this cell?
It's about color research.
Color?
The previous.
It's a previous step. So guys, you can write me on the email or maybe by other way in our Yova application, and I will send you this file with all field information, and you can try it. Okay? So I want that only maybe few person from all of you will finish our filling the gaps. I hope it's like I make like this by fingers.
I found the first.
Okay, can we move on?
Yes.
Yes, and anybody else? Yes? Does it work? Does it work?
We need your help. Что мы там сделаем? Мне кажется, уже синие. Что, они что-то говорят?
Перед точкой нужно поставить favorites.
Точка?
Перед точкой это не просто как функции.
Фотками своим.
Я уже скинул.
Как на моем
Аня, спасибо.
Пожалуйста.
Activate here on the environment. It should be made by you by it can be a problem because it's not this particular environment. That's why it should be a role. Okay, let's move on because our time is not good. Okay, the next, what we will do the next? The next, we should split the test day. This action we should do by creating DF test. And how we will do it? We will find two dates. For example, 15 of March 2020 from time 0000 to the end of the day. So we will like drop from your data one day and make this day like your test set. So we just like I don't know, misinformation about one day to make it like a test data frame. For this, you should create DF testing using lock method. Lock method make from your data frame some particular information and lock it. And then we specified the DF indexes, and you know that indexing was made by the data, so you specify this particular indexing and put this data from your data frame. As I understand, I should do like this. So, I should ask before. Okay, so you log from your data something about the beginning of the day and then the end of the day. And for other data, you log all other data that is less than this data and at the same time bigger than this data. So we use it to create our DF with all data and our DF test. For what we will use DF test? We will use it for testing our auto-encoder. So we should move from our data some part to be sure that we will test our auto-encoder on this part of data. This part of data, DF test, our auto-encoder will never see and we will never saw in training stage. So it's like a new data for it. So we will use this testing set for training or for testing our autoencoder when it will be tuned. Can I see is it was tuned or not? 1 second, guys. I want to see how many epochs. Oh, you see, first, second, third, fourth, or it's 12 epoch right now. All this time, our autoencoder tunes all of its, how many parameters? 1 second. This is a number of trained parameters. You see how many parameters, how many weights in all nodes train our autoencoder right now. And you, as I can say you, this number of seconds is number of seconds for good, powerful computer. So good, powerful laptop. So in your computer it can be in i5 with 8. I'm not sure about memory, but i5 processor, it was 15 minutes per 1 epoch. So in other laptops it can be different seconds, so I'm not sure about the time. So it's deep learning. Okay, we did it. Okay, we are at this step. So after you run in the cell, you will see information about only, I'm not sure about this part. If here is DF, you will see information about almost this part of rows. If you see information about DF test, so you see it's little part of rows, only about 1 day. 1,400 rows only. It's
Can you show please?
oh, sorry.
Yeah.
Mhm.
Can you help in this part?
And other parts after this one. Okay?
Yeah.
Okay, so it varies. Okay, let's move on.
It says something with the data. But I think everything is fine.
Date, time, hero. Can you move up? I want to see in hero. It's see date time. Date time is a correct, not data time.
Here,
Not Russian letters.
no.
Here. Not Russian letters. Here, for example. Here. No.
No, it's a перепиши снова.
You know, it's impossible that code from other guys works and you could know.
Yeah. I'm sorry.
Okay. Is it works? Does it work? Okay, Sasha, thank you.
Sasha, do you want to sit here?
I'm not sure. Okay, let's move on, guys. Again, okay.
You should start from the beginning, because probably you put this, run this cell for the second time, and this time probably have no daytime. It only have time, so you need to do everything from the beginning and everything because there was. You may get it in the same file. Just like this, close. No, sorry. Just here, we go to the beginning and just right here we can see some time.
So as I said,
At this time, it has this data frame has daytime. And I don't know why the third person. It seems like they push it for the second time. And no, it is measured than days Yeah.
Okay, and then in this notebook you should open. So it's you know, for deep learning, it's really important to use a particular environment because the sets in this environment are made for our. Is it works? What was the problem?
Just we started this. We need to run with the big window 2 times.
Okay, I don't know about this.
We started the process again from the beginning and ran every window, and on the third
It's okay. Okay, maybe you should rerun something. Okay. It's okay? Can we move on? I wanted to show you result, please. Not only fill in the gaps in my code. So, okay, we have train test, we have test data frame, and then we want to visualize. Can we please? I want to show something about visualization. Here you should fill only one line. Create a list. For creating a list, you should use square brackets. So you should use like equal, these square brackets, and inside you should print df, comma, df test. And that's all. Data set is equal square brackets df test, df, comma, df test. I think after our workshop, nobody wants to be a programmer. I'm not sure, but I think yes.
Well, I have no choice because I studied in this university.
Yeah. You are right. Okay, I'll show you how it looks like. Data set is equal square brackets df, comma, df test. That's all. And when you run this cell, you will see. A minute of attention, please. 1 minute. Can you see my screen here? You see all your data. This is heart rate from your train set that begins November 2019 and ends April 2020. It's information about heart rate each minute using 5 months. It's a big data frame. And here you can see like a little gap here and a little gap here. It's information about 1 day in March when this information we put from our data set and make from this information test data set. This information was here. So we just put it from data set and you see this information. Using this from beginning of 15th of March to the end of this day, this information will be in our test data. So please put your code here, please shift enter. It can take a little time for processing, for creating these images. Sasha, how is it?
Yes.
Okay? Anybody else? Good. Oh, guys, why you didn't say nothing? Okay. So let's move on. Make a correlation coefficient. It's with what you can run this cell. It's about, is our data, our training data, have some correlation? Maybe if the coefficient of correlation will be big, we can use, for example, statistical method, and we have no need to build deep auto-encoder to process this data, yeah? But you can see here, if you download it, so the level of correlation is close to 21%. It's about no correlated data, you see. So you can't use some linear or maybe some statistical method for such correlation level. So it's like a proof to, like a necessary to use different other methods, not about mathematical statistics. Oh, then I want to show you, I want to see by myself, pre-processing stage. So we formed our data, and right now, you know that our data is time series. So you know that we will use LSTM, I said it before, but we should show LSTM how to works. What will do LSTM? LSTM will do like a little action. It takes 29 numbers of time series, of numbers of time, will learn it, and then he will predict the next time. So it will be learned on 29 time series and predict 30th time series. For this, we should make some pre-processing of our data to create a little data frame or a little training data for our LSTM layer. And it will be like this. I open the code. Okay. So, at first, we should scale our data. It's like create min-max scaler. What do min-max scaler? It normalize our data between such levels. I think here we use parameters by default. It's from 0 to 1. So only we create our own method, scaler. Then we feed this scaler to our data frame, that consists trained data, that consists of trained data. And then we create scalar train and scalar test. We transform our data frame using this method, and we transform our test data frame with this method. And then I'll show you, for example, scale train that consists of such rows and 2 columns. And you see that our data was changed because the maximum for our data is equal to 1, and minimum of our data is equal to 0. It's like normalizing, yeah? Easy way to normalize our data. And right now, all our bit per minute and all our used calories became at the same scale, yeah? From 0 to 1. So computer, or maybe some computational algorithm, can understand that they are with the same scales. So they are, they have equal weight for, like equal informational weight to all systems of computational intelligence. Okay. This box? Next box? Okay, wait. Guys, okay?
You made it.
You missed some pieces, yeah? I'm so sorry. Girls? Uh-huh.
It works.
Good. You create your own auto-encoders. And girls? Other girls? Okay. Can we continue? Move on?
Yes.
Okay, let's. Okay, then you can run the cell scale test, and you see all these 1,400 rows for your test.
Shouldn't the I scale test because we have a gap here that we must fill?
Not gap. It's not a gap. You see, if you want to open all your 1,400 rows,
You have only one row scale test, but we have scale tests,
It
then
was to-
a gap to fill.
We didn't decide on whether to scale test. It won't show anything. Maybe it was
You see something else like in my screen?
No, I mean it's much higher up, probably where you define the skill test.
One row from your previous cell, it put it in our cell 47. The row where we should type scale train, scale test is equal to PD data frame scalar transform. The last row on your previous cell, not last, one before last, the second from. This scale test is equal to in the cell, scale test is equal to in our file should be typed in the cell next, in the next cell.
Oh, maybe, but it's not important. Yeah, but it's not important. You can.
But this was the question.
Okay, thank you. It's not important. If you run it here and then you visualize your scale test, nothing change. Only if you wanted to visualize before and run after, will be a problem.
This is again where should be.
You can put this string here or put it string here. It will be work the same. Okay. I think 1 second I will see how many. Only two blocks. Only 2 blocks. But here I have deleted so much information, so we have 4 steps here. But I want to say you why we did the previous step for this function. This function creates our data set for LSTM. It use some our data, our big data. The X data will be equal our scale train, and the Y data also our scale train. And then we move some part of time series to create these 29 time numbers, and then put the 30 time step like some time step that should be predicted by LSTM. So this function works like this. So it creates this like a window, if you want. So we took 29, this will be predicted. Then we move for 1 time marker. Also have 29, the next will be predicted. And we move this window across our data to predict the next value each time. From 29, 30 will be predicted, 29, 30 will be predicted. And we move this window. It makes our LSTM to predict our data. And you should ask why we need it. Because when we have normal data without any problem. Some you, for example, I know, go to the beach and you have some sunglasses, I don't know. So your heart rate and your calories will be not the difference between this time marker and other time marker will be almost the same like in previous steps. But for example, somebody scare you. What will be? Your heart rate make like this. And then based on some time markers, the next will be predicted with a mistake, a big mistake, because nobody knows that you was scared. And LSTM will work bad in this case. It will be like a mistake. So, based on prediction made by LSTM, auto-encoder couldn't renovate your information by the good way, because LSTM makes mistake. Auto-encoder will do the same. So this particular part will be like an anomaly in our data. So it's like a way to find this anomaly. Autoencoder use the LSTM approach that LSTM cannot predict this particular time marker, and then autoencoder makes mistake too, and it will be shown in error function of our autoencoder, and we will see that it will be anomaly in our data. So, does it works? Okay, you see here the shape, X-train shape. So it's like a dimension of our data. So you can see that shape is like in space have 3 dimensions. It's like so many these arrays multiplied to 106,000 ways. It's like many little data frames inside one X-train. And inside one X shape, just information about time series, predictor. Okay, let's build our model. Again, it was reshaping, and we should build, about building our model, it's not your way, you shouldn't do nothing. I'll show you that we create a model by Kera sequential that help us to build layer by layer our network. Here we add some layer, Kera's layer, LSTM, with some nodes. So this layer will be like LSTM layer with some nodes. Input shape will be X-train shape 1, X-train shape 2. So this, then this. And it returns, sorry, it's about, because I make it bigger, return sequences, and the name will be encoder 1. Then we create a layer, it's about sparse autoencoders. Layer that drop out 20% of our neuron. It's about freezing. This neuron, this number of neuron, it will be it will be taken randomly, but this part of neurons never trained in this layer. Then we create again LSTM layer, but it became smaller. It's like encoding here.
I have a question. Don't Python arrays have indexing from 0 on? That means that it's not shaped.
Oh no. Yeah. Sorry. It's about, yes. We take this sequentially, but we take this information. Yeah. You're right. Sorry. It's about our little part, yeah? It's like we divide our data set, but these parts, and it's a number of its parts. So we took this part, of course, of our data, then we create LSTM layer, smaller, so it's like encoder, yeah? Return sequences and the name of layer. Again dropping out, like freezing some neurons. Then the new layer, also encoder 3. So you see our encoder contains 3 layers. 3 layers, it's about deep. It's like 6 layers at all, but here we will repeat our layer. It's like the part that consists a bottleneck. Here we name it encoder-decoder. And then we begin to decode our data, to renovate our information. This way, 32, 64, and 128 nodes. And then we see time distributed by the Keras layer dense, and unit was taken from this data, it's like 2. the loss method will be mean absolute error, and the optimizer will be RMS probe. I said it before when I said about PCA and auto-encoder there, it was, it's like this optimizer is inside our Python, so we shouldn't create formula by our hands. So when you run this, you'll see the structure of your autoencoder. So first layer STM, then dropout, then LSTM, dropout, LSTM, repeat vector for bottleneck, and decoding. And you see here total parameters of our model. You see so many parameters, and you see the number of our training data. I said that the number of our training data should be more or equal to the number of parameters. I tried to use a smaller autoencoder without, for example, 64, 32, 16, 16, but it was only 16,000 of parameters, and it became overfitted because of number of my data. So I think if you took a little bit more data for this autoencoder, it will be learned better. But in our, we have no big amount of time for training it. So we have this, and then you shouldn't run anything more, because you should only fit your model. You can put this code inside this cell. It's like your model at previous cell was fit to your X train. To renovate your X train by 15 epochs with batch size like this. You should use different batch sizes, but I think for our data and for our encoder is the better way to use this batch size. You can make it bigger or make it smaller, it's your choice. You shouldn't shuffle your data, it's really important, because you have time series, nothing about shuffling. And some other parameters I used for this, and I trained my autoencoder here. Okay, you did this step?
Yeah.
Okay, let's see what, so you can save it and run at home. Today it's not about running here. Okay, let's see what we have. We have here loss, the value of our loss equal to 0.0185, but we started from loss 0.0381. So our loss function became smaller, 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 and here we can plot it. I will run all these cells to make it better to see. It was our training loss, it was our validation loss. It's good, because our training loss should be bigger than our validation loss, and our test, it's necessary to be smaller, or maybe at the level of validation. But you see, maybe if we will have more data, or maybe a little bit more data, this validation loss will be a little bit lower. Yeah, because it's like number of parameters and number of our data are equal, but data should be a little bit bigger. But, or maybe other architecture a little bit. So, let's predict what we done. Predicting, creating X predicted from our model to our X train. What we do? We show to our model X train again. And plot the data together. It will take a little bit time. So I want to show you our data and then renovated data. So how our autoencoder renovates our data. It takes time. It's only one epoch, yeah, only it's like calculate all these parameters using new data. And it's not new data, the same data.
And we have 15 epochs.
In learning, yes, but you maybe should use more epochs and it will be better. But not in this workshop, you know.
Then I split it down for 9 because one epoch takes approximately 10 minutes.
10 minutes, yeah. As I said, in i5 computer it was 15 minutes, so. Okay. You know, my computer don't want to do it. I don't know why. You know, I wouldn't run the cells. Here we see predict, oh no, you see. So much time. So if you will run at home your code, be ready to wait. So make your coffee, I don't know. See some TV series during learning. Okay, this heart rate prediction, this heart rate training. You can compare and see, for example, this gap here, here, here. They're not the same, but close to be the same. How to understand? Is it the same or no? It's about colors also. Training prediction. Not the same, but the form can be close to okay. Let's calculate error. And we see that we had a big error, then this error became lower, lower, and we have something about this value. Okay, let's predict on test data. So we use our test data, make prediction like we did at train data, but test data smaller, so I think we should run it here. We have heart rate test and calories test here, and then we should calculate these 3 blocks, and then it's our result. See, you see here, I make, 1 second, I show where here, threshold parameter. Threshold parameter is a function that can like find some line bigger of this line, we detect anomalies. Lower of this line, we detect normal data. So this threshold parameter for our data is close to 97%. So this value divide our data to false without anomaly and to true with anomaly. Anomaly is here. So, and you can say, oh my God, it's like linear separated to data and what? But you see, it's our loss function. Let's see this data on heart rate. Oh my God. So this point was predicted by LSTM with mistake. So something happens here. Here, it's understandable, it's like heart rate makes like this, it's impossible to predict without any additional data. But for example, here or here, why? And let's see what happened with calories. Also, all these anomalies was mixed inside your data and you can't find it by some threshold function or something like this, because this data is normal, and these are anomaly data. And you can find it here by reconstruction of auto-encoder by auto-encoder, but you can't find it another way inside your data. So autoencoder can be used for information finding some anomaly in your information by this way. So you have a link for downloading data, you have autoencoder made by you, and you have a paper that describes how it works. You also have here a link for this paper. You should try to make your own prediction based on maybe different person from your data frame, or maybe by different date. You should use for testing not this date and other date. You should visualize this row to see any characteristic of this row, and you should use it in your normal life. Yes.
Can it be used for analyzing signals, for example, APG or AG signals?
Yeah, but you should do the prediction or the pre-processing of this signal to be possible use here.
Yeah, I just found a lot of signal reportings. They want to analyze something.
Yeah, you should understand how LSTM works, what you should do for LSTM. For example, you should use this window, it's like some part of moments of time, and you should move it across your data. It's not complicated, I think. So that's maybe all. And today we have right now a time for Q&A session.
Lecture and workshop a bit complicated. So respect. Actually, your question, please. I think after lectures and workshop, there are many questions.
So you said that there is some link for explanations.
Yeah, in my here we can see here. You can find a link about this experiment made by different data, but it was there we have different data, different result, and you see where you can find description of time series, and here you can see where you can find the data sets that I took for our workshop.
I'm interested. Which data are you processing?
Is data about Fitbit smartwatch with Fitbit. But here you can find different data for different smartwatches, but not about
We just had some virtual project with my student, but with Garmin watch.
no,
We registered PPG signal, and then it was also. I should take a look what has been done by you. Unfortunately, I wasn't able to do it.
You can download my presentation.
Yeah, of course, and we just streaming it via YouTube, and then you can find it on our YouTube channel, so no problem, if you don't mind.
Yeah, of course.
And then, so we just tried a few machine learning methods, and now I'm going to switch to deep learning, but yeah, of course, we should discuss it later. So thank you, Iryna. Thank you. And now it's time finally for coffee break.